Hello students, welcome back to Mathematics for Everyone. In this video, we shall take the SARS diagram method to expand a determinant of a square matrix of order 3. Then after that, we shall take singular matrix, non-singular matrix, minors and cofactors of a matrix, and also take problems related to these. So first of all, I take source diagram to expand a determinant of a square matrix of order 3. Source diagram. The determinant of a the determinant of a square matrix of order 3 can be calculated as follows. First of all, enlarge the determinant by adjoining the first two columns on right hand side. Then draw broken lines parallel to diagonal and perpendicular to diagonal Then we take sum of products of elements of broken lines parallel to diagonal minus product of elements of broken lines perpendicular to diagonal. Then we take a square matrix and we shall apply all this. Consider a square matrix. Let Q is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33 is a square matrix of order 3. Now we want to calculate determinant A11, A12, A13, A21, A22, A23, A31, A32, A33. As we have already written, first of all, we shall enlarge the determinant by adjoining the first two columns. So we write A11, A12, A13, A21, A22, A23, A31, 32, A33. We shall enlarge this determinant by adding the first two columns A11, A12, A21, A22, A31, A33. Then first of all, we draw broken lines parallel to diagonal. This is a diagonal. This is a broken line. This and another broken line parallel to diagonal is this one. Another is this one. So these lines are parallel to this diagonal. Then we take lines perpendicular to diagonal. Perpendicular to diagonals are this. Another is this one. Then next is this one. So these are lines perpendicular to diagonal. Now this will give you sum of products of elements of broken lines parallel to diagonals. We take sum of products of these. First of all, we take first A11, A22, A33, A11, A22, A33. Second line parallel to this is A12 plus A12, A23, A31. Then third is plus A13, A21, A33. So these are the sum of products of elements of broken lines parallel to diagonal. Minus, we shall take sum of products of elements of broken lines which are parallel to diagonal. So this is A13, A22, A31, A13, A22, A31. Then second is A11, A23, A32 minus A11, A23, A32. Then minus third is A12, A21, A33. So in this way, we can calculate this. Now you will add and subtract all this and you will get the result. So this is how to expand by Sart's diagram. Then we are taking singular matrix. Singular matrix is square matrix P is said to be singular if determinant of P is equal to 0. Second, non-singular matrix. Non-singular matrix. A matrix, a square matrix Q is said to be non-singular if matrix Q is not equal to 0. For example, for what value of x? For what value of x? Values of x, the matrix A is equal to 1 plus x, 7, 3 minus x, 8 is singular. Solution: since matrix A is singular, therefore determinant A is 0. That means determinant 1 plus x, 7, 3 minus x, 8 is 0. This will give you, we shall expand it, 8 plus 8x minus 21 plus 7x is equal to 0, which will give you 15x minus 13 is equal to 0. 15x is equal to 13. X is equal to 13 by 15. Then we take minors. Minors. Let A is equal to Aij is a square matrix of order n. Then the determinant of a matrix of a square matrix of order n minus 1 obtained by leaving the ith row and jth column of the given square matrix A is called the minor of element Aij and is denoted by Mij. For example, number 1, let P is equal to, let square matrix P is 6 minus 8, 2 minus 4. Then M11 is minor of 6. M11 means you will leave first row and first column. Leaving first row and first column, we are left with minus 4. then M12 is minor of minus 8. 1, 2 means you will leave first row and second column. First row and second column we are left with 2. So 2 is minor of minus 8, which is M12. Then M13 is equal to minor of 2. That means M12, M21, M21, this is A21, so it is M21 is equal to minor of 2. You will leave second row and first column. This is second row and this is first column. We are left with minus 8. Then M22 is minor of minus 4. So M22 means you will leave second row and second column. This is second row and this is second column. We are left with 6. Similarly, we take another example of third order. Let Q is equal to minus 2, 3, minus 7, 4, minus 5, 9, then 1, 6, 8. First of all, we take M11, which is minus 2. M11 is minor of minus 2 because minus 2 is the element A11. Then M11 is minor of minus 2. M11 means you will leave first row and first column. We are left with the determinant minus 5, 9, 6, 8. Once again, you will leave first row and first column. First row is this, first column is this. We are left with minus 5, 9, 6, 8, which is equal to minus 40, minus 54, which is minus 94. Then M12. This 3 is element A12. First row, second column. Minor of 3. So you will leave first row and second column. First row and second column, we are left with 4, 9, 1, 8. So this is the matrix obtained by leaving first row and second column. So we get 32 minus 9, it is 23. Similarly, M13. M13 is minor of this minus 7. Why? Because minus 7 is A13 is minor of minus 7. You will leave first row and third column. First row and third column we are left with 4, minus 5, 1, 6. So we are left with 24 plus 5 is 29. Then similarly, you can find all these. Similarly, we can find M21, M22, M23. Similarly, this is M31, M32, M33. So that's all. In the next video, we shall take cofactors and the problems related to singular matrix, non-singular matrix, minors, cofactors and also problems relating to determinant. Thank you. See you in the next video.